morning. Good morning, guys. Welcome to, so hopefully you can hear me. So today we have our last, if you will, this is our last lecture, if you will, our last topic. So let's take a look at the calendar. Actually, I have some students here. I don't know why they're here. They're not in this class. All right. So today is what? Monday, right? Okay. All right. So let's take a look at the calendar just to see where we are. So if you look, you can see here, I've updated the calendar. And we are on week, today is the April 19th, right? We're basically the last week. I want to remind you guys that next week is your term project presentation. So on that day, I'm not planning anything. You know, we're just via this medium Zoom. You can just do your, I'll give the floor to you and you can just do your presentations. Okay. And then we'll have a course wrap up on that Wednesday, basically. And then this week, today, I'm going to discuss the last topic, which I think you will find, enjoyable, right? Both of you have taken, I know Ryan is in 362. Jacob, have you taken 362?
Which one was that?
362 is a distributed, the PHP class, PHP and jQuery.
Yeah.
Okay, great. So, and then I know Ryan is in it. So basically, you guys have some basic knowledge, and so this should be very straightforward to get. So as you can see, here is everything for the week. Obviously, I'll post a video later. The topic is called Deploying TensorFlow Models to the Web. Okay, so that will be the topic. So basically, as it is what it sounds, right? We're going to take our Python TensorFlow models, which we learned last week, and then you would, I'll show you one of several ways in which you can add them to your websites, okay? So that's the last topic. Maybe on April 28th, I'll do like some miscellaneous topic, but really at this point, we're at the end of the semester. Also, I remind you, you'll have your final exam. At some point, it'll be pretty straightforward. Okay, so really all you have left is your presentations. Don't forget you have to do, you have to talk, you have to, talk about your project, demo the results, and, write a report basically. So I can have something that you submitted. And then your written final exam, very similar to the other ones. Okay, any questions about the rest of the semester, guys? Are there any questions before we start with the topic today?
I don't have any.
Okay, good. And then as you can see on Brightspace, you should be seeing Brightspace now. We've covered all these topics. We actually did, we went through all the topics I wanted to cover. So I'm happy about that. So you can see last week we covered basic Keras and deep learning. If you have any questions about this, I would really like you to implement this in your project, right? So if you have any issues, Wednesday, you could we can use it just as a workshop. I don't think this topic will take that long, to be honest. So definitely on Wednesday, anything related to this. But today we'll touch on TensorFlow once again, as we are deploying TensorFlow models. And that's it. So that's the semester. All right. So at this point, if there are no questions, I am going to then begin. I'll start the recording. So let me stop sharing here. Let's see what this student. Alec, are you in the wrong class? This is 362.
I am, my bad.
Okay. All right, so so let me now begin the recording. All right, so I'm gonna, We were always recording. Oh. All right, so we are now recording again. Audio is on. Let me know if you have any issues with the audio. So let's begin then with the calendar, pretty much. So as you can see, I have, this website. It's a server. So the question is, how do you deploy your TensorFlow models into the web? So as you guys know, you guys have taken a lot of Linux and Python and other languages, so you're pretty good at it, I would think. But not everybody in the world knows Python or wants to run an application like that, right? So usually the medium that we all use, the amazing thing about the digital age is the internet, right? So we want, you want to share your models with your friends, with your classmates, with your colleagues at work, with your boss, with your coworkers, with your parents. You build an application for them. Whatever it is that you did, right? You would like to make it available via the web. You want to make your machine learning, deep learning model available through the web. So there's a couple of ways, that you could do that. There's like 3 ways that we can talk about. All right, so let me go to the whiteboard actually for this. There's at least 3 ways, right, that you can deploy these. We will obviously just talk about one way, which is the one that I prefer usually for these types of, for small types of things. So, ways, we want to deploy to the web, right? So there's basically 3 ways that we could think of at least. One of them is just a standard build a local application. So local application. Somehow you build like a C++ application, and then somebody has to download it to their computer, and then they have from the website, so they have to download, and they have to install a lot of programs and then run it, kind of with a GUI type of thing. So that's one. That's probably not the best one. The other 2 are basically the one that we're going to talk about, and then there's another one. So let me talk about the other one. So this is the one that we're going to talk about today. So here, the third one would be what is called AI or machine learning as a service. Okay, so there's a lot of companies out there. Let me just 1 second. There's a lot of companies out there that will do this. Andrew NG, for instance, the guru in machine learning. He's got a business in this nowadays, and basically what they do is they provide AI as a service. So what that means is they'll probably figure out an architecture to have daemons running on servers, right? So they'll open a port and they'll have it tied to some kind of a daemon or some application they have developed, and this provides AI machine learning. And then you have in the web, right? And then people connect and everything. But this this requires a lot of work, right? A lot of development. There's security here. You guys know all too well about opening ports on servers, the implications. So there's a lot of overhead for that one. But probably in terms of scaling, I have not benchmarked these, right? So I don't really know that, okay, yeah, definitely this one will be faster, but probably my intuition tells me that this one scales the best, right? So for high deployment, that's probably the best, distributed servers, etc. The other approach would be So the next one, this is the one that we're going to talk about. And this one I like. I really like this approach. I don't know how well it scales. There's there's a few limitations of it, but it's certainly very powerful. It's certainly very much powerful. And it's, if you guys, so what I will say is this, if you guys, want to really start thinking about how to make AI, machine learning available in your websites, in your applications, you probably want to start here. Okay, you probably want to start here, and then as you take this to the limits, right? As you take this to the limits, maybe you can start looking at other options. But certainly this one is where I think you should start. So what are we going to do here? So here, we're going to do the same, right? We're going to have a server. So and I have a link I'll show you in a sec. You'll have a server, and the server will have a web application, like a HTML, let's just say. Could be PHP, but let's just say my example today is pretty simple, so HTML. Right, as you guys know, when you talk about websites, you have the client side and the server side, right? And you guys learned probably on the client side something called JavaScript, right? So you guys remember that, JavaScript. As it turns out, JavaScript, nowadays there's old JavaScript and new JavaScript, and JavaScript can also be done on the server side. On the server side. There's a lot of tools nowadays for this, okay? There's a lot of tools for this. So your HTML page will basically need JavaScript, but it'll need some additional new libraries that are available out there, in particular the server-side JavaScript. So here, when you talk about server-side JavaScript, just like you talk about PHP, you have something called Node.js. Node.js, so I do recommend if you have, JavaScript is certainly something that, take a look at more. It's very, very versatile language, the new JavaScript. And then the Node, very powerful, and then Node.js. And the people at TensorFlow have created, believe it or not, TensorFlow Js. And what's great about TensorFlow Js is that it allows you to, in particular, what's important about it is it allows you to manipulate data and convert it into tensors. So that's one of the advantages. So TensorFlow.js will allow you to take any input that you get from text box, et cetera, and converts it into tensors. Okay, so that's one great thing about it. So certainly probably don't learn TensorFlow JS first. Start with new JavaScript, and then move to Node.js and then to TensorFlow JS. You don't have to spend too much time on any of these, just a little bit to get a feel for how they are. Eventually you'll get a feel for how they are. But the point is that TensorFlow JS allows you to create tensors, and it allows you to run TensorFlow models. Runs TensorFlow models. All right, now the great thing about it is we can still do a lot in Python, right? So this involves then, let's say this is your laptop, right? Your laptop there. And in your laptop, you're running Python. And you're just doing, pretty much what we've done all semester, right? So pretty much everything that you did all semester, you still do. So you run everything in Python. You do the train test, you run the code, you take a look at it. Once the code is done, once the code is finished, and you've tested it, you have the option in Python to save the model. So you save the model, and you're going to save it as a .h5 file. That's it. You create this file called .h5. Okay? Then once you have this file created, the next step is you're going to take that .h5 file, right, that you have created, and you're going to use an application called Tensorflow Js Converter, right? So there's Tensorflow Js Converter. Okay, it's an application. It takes the H5 file and it will output a couple of files. One is going to be called model, I believe, .json. So it's an instruction file, and one is going to be a bin file. It's going to have some long name, bin. The bin file is a C-type file, right? You know, binary file that's going to be able to run really fast. And this is what contains the model. So all the model, the weights, everything. You remember that the whole point of deep learning is to learn the weights and the biases. So this file will contain it. So then what do you have to do? All you have to do is in your server where you have your web application, right? Where you have your web application, now you're going to have a folder, right? So you have a folder, and in that folder you have, you're going to have now your HTML file plus your JSON file, right? Plus your JSON, plus the bin file. You have to move these two files there, plus your HTML. Remember, your HTML is the one that also has Tensorflow.js. So similar in concept to how you guys, you know, when you have an HTML, you have JavaScript, you have jQuery, you have all these other things, okay? So that's the basic pipeline. It's pretty straightforward, really, and that's what we're going to do today. Now, the models that you build can be any type of deep learning model, right? Any type. And then you just have to remember that how it takes the data, right? The inputs are going to be X's, etc. And so then you have to be, you have to use Tensorflow.js, right? This one, to be able to convert the data that you get from your text boxes into tensors that will fit the model in the file. And that's the basic pipeline. So now, now that we've talked about it, what we're going to do is we're going to, you know, see it in action. So let me stop this. Now let me share back to the browser. So you can see here in the browser, I have a couple of things, right? So I have the code. I already posted the code on GitHub. You can see I have the binary there. I have the index page. I have the model.json that I just talked about, and that I have the actual Python. So this is the Python model that generates the, well, yeah, this is the Python model, basically. So we will start with this. We will start with this, right? Create this model, create the H5, save it. Then we're going to use the converter. It'll generate model.json and this one, the binary file, as you can see there. And then once we have that, we will move all of this to our Ubuntu server, Windows server. And then we will basically write the code for the index.html. That's where, you know, you have to know a little bit of JavaScript, of course, or, you know, just be willing to learn it a little bit. And that's it. All right, so now if I go back to the links, so you're seeing this, right? So you can see here, I have a demo, actually. I have a little link of a demo, so I'm going to click on that. And there you go. It takes me to a website that I created, just very simple for this class. It's called ML example. You can see it is, I have a folder called Tensorflow.js where I have all those files. And then as you can see here, what it does is a very simple machine learning algorithm. In this particular case, I give it numbers. And it's going to tell me if it's odd or even, right? So for instance, if I say 13, right, and I click on predict, you can see it says odd. Can you guys see the pop-up that says odd?
Yeah, I see that.
And then if I do something like 4,000, which should be even, right? And I click on predict, and it says even. And all of that, believe it or not, is not being done through some kind of if statement, which you could have done, right? It's not an if statement or a modulus operation. It is actually a neural net that was trained on some data, a supervised learning model, and it learned. So actually, one good thing about this is that if we could have made this perfect by just having if statements and modulus, right? But I actually I can prove that it's a machine learning algorithm because it does sometimes make mistakes. You know, an if statement and modulus would not make a mistake on this. But take a look. If I do 47, I think it'll give me an error. Even, right? Do you guys see that it says even?
Yeah.
Yeah.
And that gave me a little bit of intuition. I think the model learned that when it saw a lot of zeros like this, it learned that those were always even. If I gave it numbers that were, you know, like started by 1, it always made them odd. But there are other numbers where it has a bit of trouble, right? So 531 even. You see that it did not get correctly. And that's the kind of thing that only a machine learning algorithm makes, right? You know, those kinds of mistakes. Obviously, now don't feel bad if this is not always perfect, because that's not an issue, right? You know, this is just like any other machine learning algorithm. So any machine learning algorithm that you could have built on Python, you know, we can deploy here, right? And the key thing is, what the website will do, what the Tensorflow.js does, is pretty much take whatever inputs you give it via text boxes, drop downs, uploading an image, you know, something like that. The Tensorflow.js would grab that, process it, and convert it into a that would fit into your .h5 model. Okay.
Yeah, like some random number ends with 1.
So that's the basic idea. Okay, that's the basic idea of this. All right, so this is how you would deploy the machine learning algorithm. All right, this is the example. So now what we're gonna do next is we're gonna go to we're gonna develop our, now another thing that's important is that this is independent of operating system. So you will see me that I will so you will see me that I will develop the machine learning algorithm in Windows, right? So with, you know, the Anaconda, right? I'll do it there, and then we'll deploy this on a Linux web server, right? And that's, you know, completely just like the web is independent. This is independent of operating system, so you know it's pretty good that way. All right. So anyway, this is the example. As you can see, very simple, but it will show the exact pipeline that we want to do. And as I said, all the code is here. So now let's go ahead and start developing this. All right, so the next step then is I'm going to stop sharing this, and we are going to go to the Anaconda environment. So let me actually create a folder. Okay. All right, so we're going to go then to the Anaconda prompt. All right, and I'm going to create a file here. One sec. Open this file, Notepad++. I'm going to share the screen. You can see here, I'm sharing this is where I'm going to create the file. I'm also going to go into the prompt. And there's one important thing that we want to do. So actually, I want to share that prompt. All right, so you can see, you are seeing the prompt, correct?
Yeah.
All right. So as you know, with Anaconda, you have the option. With Anaconda, you have the option of creating multiple environments, right? And so for instance, if I do conda environment list and I take a look at it, I can see that I have several environments, right? So I have all these environments here, right? And in the other day, when we were looking at TensorFlow, we created an environment. We created an environment. And so because this is going to have some additional programs, I'm just going to create a new one. Later on, if I don't want to use it anymore, I'm just going to delete it, okay? So I'm going to go ahead, and the first thing I'm going to do is I'm going to do conda create, and I'm going to say -n, and I'm going to call it TF version 2 web, okay? And that's just a little environment that I'm creating. It's going to have its own little libraries, so I can just later on, get rid of it if I don't want it. But I'm going to use it for the class. Okay, so I'm going to say, yeah, that should be fine. So conda create -n TF version 2 web with TensorFlow installed on it. Right, so I run this environment. I'm going to let it install, and that way now this will be the environment where I'm going to do this application. So let's let it install for a second. All right. All right, and there it is, right? So now I've created the environment. And now the next step is I'm going to activate it. So I'm going to do conda environment list. Right, and you can see it there. So then I'm going to do conda activate TF version 2 web. Right, and now I've created the environment. I also want to install a couple of libraries just in case. So I'm going to do pip install Keras. Are you guys seeing this? You are?
Yeah.
All right, so we're going to install, all right, so we install Keras, and then we are going to install also sklearn just in case we need it. Probably won't. All right, so there we are. So now this is pretty much what we did last week, right? So we have an environment now. We can also navigate to a folder. Okay, so we're going to go to ITS 365. All right, and here we are going to go to hold on. We'll go to JS script. And then I'm going to go to class example. Okay. All right, so here we are. This is the folder where we're going to do our development. So basically, we have our environment all set now. And now the next step is going to be to install Tensorflow.js, because we're going to need a program called Tensorflow Converter. All right, so Tensorflow Js Converter. So we do pip install Tensorflow JS. Should be just like that. So pip install Tensorflow JS. Okay, that one. All right. And now we are ready. All right, so we are ready to go. Okay, now the next step is, obviously we can't convert anything yet because we don't have anything. So the next step is we're gonna create a very simple machine learning algorithm. So now I'm gonna share the screen. So you should be seeing Notepad now. And we're just gonna, just like we did last week where we learned TensorFlow, I'm going to, use TensorFlow now. So import TensorFlow STF, import, NumPy as NP. Okay, so we add a couple of libraries there. Okay, and what's great about this is that the libraries, everything, they will be, all organized into a way that doesn't require any additional installation once we deploy this to the web server, right? So in this case now, I have, first thing is I'm going to need some data to train, right? I'm going to need some data to train. So this, obviously we could do this a lot more complex, but I'm going to keep it simple. So we're going to create X and Y here, right? So we have our X and our Y. And then I'm going to do for, ignore the value just so I can do several repetitions. So for range, let's say 10,000. So I'm going to give it 10,000, create 10,000 samples. 1, 2, 3, 4. And basically, I'm going to generate some random numbers there. So I'm going to say num is equal to np.random.randint. Now keep in mind the numbers that are generated, right? You can view them, but they're going to be in a specific range, right? So let's say a range from 0 to 101. Okay. Now you can play with these values, try to add larger numbers. Okay. And so now that you have that, we can do x.append. And so the x is just going to be the number, right? So the x, we're creating a list. The x is just a number. So if it's 3 or it's 8 or it's 17 or whatever, it's just a number. But the next thing is the label. So we have to say if something is even or odd. And usually to do that, we can easily do that with just a modulus operation, right? So we're going to take num modulus 2. Remember that what this does is that modulus is a division, but it only takes the remainder, right? The remainder of a value. So whenever you guys, if you guys remember how you used to do division, and then you would end up with a little remainder. So the remainder based on this, when you do this operation, it's going to be 0 or 1 basically. Okay. So we can actually take a look at this if we'd like. So let's see here, just a few. We're going to say print num and print num modulus 2. Okay, so I'm going to also add an input here just so I can stop it. All right, so let's take a look at this one. I'm going to save it. We're going to go to the, oh, I need to share now the prompt, right? So let's go back to the prompt. So you guys should be seeing the prompt. So I do dir. There is the Python script. So I'm going to do Python class web. And there we go. It's going to load TensorFlow, hopefully. All right, it's taking, all right, so there's 56 and 0, right? That's correct. That's it, that's even. 71 and 1, 8 and 0, 69 and 1, 64 and 0, 84 and 0, 40 and 0, 99 and 1. Perfect. So it's working. Okay, we can kill it. All right, so that's working perfectly. So now let's share back to the this one. All right, so you can see we can get rid of these three, right? We know it works. Now we have our data. And now that we have our data, what we're going to do is we're going to build a model. That's it. You know, we're going to keep this very simple, but you could build something more complex, you know, process images, etc. You just have to figure out the part in Tensorflow.js. So now in here, we're going to build a model. So we're going to use Keras here. So I'm going to say model equal tf.keras.sequential. Okay, so just like before, you know, pretty much the same thing. So we can see tf model Keras sequential. We've got our model created. Now we're going to build a neural net. Let's just build a complex neural net. Why not, right? The model add, and we're going to say tf dot, just like we learned last week, tf dot Keras layers dot dense, right? And then here we need to, in the first layer, we'll specify the input shape. So input shape is going to be equal to, now we only give it one value, okay? A value between 0 and 100. We could do this in other ways, okay? We could definitely do this in other ways, but for now, we're just gonna do it like that. So it's like we're giving it a continuous value, one or x1, which is any value from 0 to 99 or 101, right? So, and that is going to be mapped to units equal 64 or whatever number you want. And the activation in this case will be sigmoid. Although it could be relu or something else, you know, let's just go with the sigmoid function. Okay? So again, what does this mean, right? So, you know, just to kind of do a review of what we covered last week, let me save this before. Let's go to the whiteboard and let's just think about that. So that model that I just created is got an input of just that one layer, right? Just that one layer is basically the input. It's basically the input, right? And we have just one, right? X1, which the value can be from 0 to 101 because that's what we trained on. And then I said that the first hidden layer, hidden one, is 64, all the way to 64. Dot, dot, dot. So that's, you know, all those connections, right? Think about it, all those connections. All right, and that's basically what, you know, what I've done so far in the model. So now I go to the next part. We're going to go back to the Python code. And I'm going to, and please stop me if you have any questions or anything like that, please. All right, so now let's do another layer. So I'm going to do model.add. And I'm going to do tf.keras.layers.dense, right? And this is going to be units equal 32. And, you know, so we're, you know, activation. So we'll take a look at that in a second, but activation is equal to sigmoid. Oops. So sigmoid, just like that. And then model.add tf.keras.layers.dense. And this will be units equal 16. Activation, again, is going to be sigmoid, which we've already talked about. And a couple more. So like I said, this is a very deep neural net for this problem. tf.keras.layers.dense. Dense. Units is 8. Units is 8. Activation, once again, is sigmoid. Okay, and then let's see. One more, the last one, model.add, and then we'll go back to the whiteboard and take a look at this. So tf.keras.layers.dense units in this case will be 1. And that's the output, right? So we want to predict either a 0 or a 1. Sigmoid will be a 0 or a 1. So then activation equal sigmoid. Correct here, correct there, parentheses, and there we go. Right, so if we do that, then that's the architecture. So you can see usually deep learning algorithms taper. They're like a funnel type of thing towards the end. So you can see here, if we go back to the whiteboard, we got 64. Then we've got a second hidden layer. Let's call it hidden 2. And this one has 32, I think it was, right? And then we have the third hidden layer. And that one's shorter. It's got 16. And then we've got a fourth hidden layer. And that's 8 neurons. Right? So all these connected, 8 neurons. And then finally, I think the last one was, the output, and it was just 1. So, right? And all of them, remember, are running through sigmoid functions. So all the values need, before they move to the next step, need to be passed to the last, need to be passed through the sigmoid activation function. Even the last one, actually, is sigmoid. Okay, so that's your deep neural net, just like that, right? So if you look at it, if we go back to the code, we can see that that's what we built from 64. Actually, it started at 64. Did I not do 64? No, I started at 64. All right, good. All right. right, so as you can see, that's, let me grab some coffee. All right, so as you can see, we've got our deep neural network created. It takes one value, which is going to be X, and it's going to predict one value, the Y, right? And it's a neural net from 64, 32, 16, 8, and 1. So here again, if I do the whiteboard, just don't forget that if this is X, this is Y, okay? That those are the, it's a supervised learning model, so it learns from this. So now, let's finish it up. Believe it or not, we're almost done. We can move to the next step. Let's just do the model, compile, right? So I'm going to do model, compile. You can do model summary if you'd like, but I'm just going to do model compile. I'm going to use what is called the Atom optimizer, Atom, and I'm going to do the loss function, which in this case is called binary cross entropy. Remember, it's only two classes, 0 or 1, even or odd, right? So we can use binary cross entropy, which we've already talked about. These are the similar things to the loss function for the logistic regression that we talked about in a previous lecture during the semester. All right, so model, compile, Atom, binary cross, just making sure I don't have any typos, cross entropy. And then now, we fit the model. So let's do model.fit. And then what do we fit it with? X and Y. All right, we're not going to have like a validation or anything like that. We're just going to train. So X and Y, and we're going to use the number of epochs is going to be equal to, let's say, 100. Remember, what that means is that we will look at this data set of 10,000, right? And the model will run through that. You know, imagine it's a bucket of 10,000 X's and Y's, right? It's going to look at that bucket 100 times. So it goes through the bucket, you know, all 10,000 once, then again, 2, 3, you know, until it reaches 100. That's what the number of epochs means. All right, and that's it, right? So now the model's ready. We can train it. So I'm going to go ahead. I save it. Now we're going to go to the prompt. Oops, sorry. I'm going to go to the, I need to share the prompt. So I'm going to go over here. You guys should be seeing the Anaconda prompt, the black screen, right? And now I'm going to run my script, right? So it's going to show the train, it's going to show the loss function. So I'm going to do Python class web ML, all right? I run it. Oh. So this should be model, not mode. Okay, so model, fit, okay, save, share back the prompt. All right, once again, run it. All right, there it is, right? So it's training. You see the loss function should be going down, hopefully. We didn't put in like accuracy or anything like that. That's why it's not showing the accuracy. But, you know, it's training basically. 65, so that's good. All right, and it finished, right? So we did the training. We have a model trained now. Are there any questions so far, guys? Any questions?
Not here.
All right, great. So now that we've done that, okay, now that we've done that, there's only one step left. And the step that's left is basically to save the model. So we need to save the model H5. So let's do CLS here. If you do dir, you can see there's only one file in here, and it's the class web. But now we need to have another file, which is called a .h5 which is the Keras format TensorFlow model. All right, and to do that, it's very simple. You just do model.save. It is literally that simple. So model.save, and then just give it a name. All right, so save it, you know, let's say model .h5. Oops. H5. All right, and so now when the model finishes training, right, we're going to save it. Obviously, you have to do it after training because you want to save. This is what saves the weights, the architecture, etc., so that you can use it later on. So I'm going to do model.save model.h5. Okay, so now I'm going to do this one, and then I'm going to go back. I'm going to run the code. At this time, I'm going to have my output. So let's go ahead and do that. Run it. It's going to train again, right? But at the end of that, we're going to have the H5 file that we need to use to deploy this to the web. Now, again, hopefully by now you can see that you could use other data, you could use other architectures for your model. So you can build now any kind of machine learning algorithm, deep neural net, and then basically deploy it to the internet. So now I take a look at this one, and I'm going to do the dir thing, and there it is. There's my model file. Okay, model.h5. There it is. Right, if we take a look at it, you can see it's actually not that big, right? It's not that big, which is a good thing. It's only about, what is that? You guys probably know this better, like 78 KB. All right, 79 KB, whatever. All right, so you have the file now, all right? And now comes the reason why we installed that program. If you remember here in this environment, in Anaconda, I installed that one, right? Tensorflow Js. So what I need to do now is we can't use directly, we cannot use the H5 file directly on a web. We have to do a step in between. And the step in between should be quite simple. We're going to take that H5 file and we're going to create a new set of files. It actually creates a couple of files. So this is going to also create a folder in this directory. So I'm going to go ahead and just run it. So I'm going to do TensorFlow, which is the program we just installed, JS. All right, so TensorFlow JS _ converter. Okay, and we're going to say the input format. So other input formats are allowed, but here the input format will be equal to Keras, okay, which is that .h5 file. And then we're going to give our model a name, so we can just call it model.h5, okay? You see that there, or you could try another name if you'd like. And then we're going to specify the directory that we want to create. So let's call it model.js. Okay, that's the folder. Notice that that folder doesn't yet exist in here. And that's it, right? So once this is done, if everything works out, I'm going to hit enter. All right, so no errors. So I do CLS, now I do dir. And there it is. There is my model.js folder. Notice that the H5 is still there. My Python script is still there. But now we want to go into model.js, right? So let's go in there. And now I do dir. And as you guys can see, there are two files in here now. The model.json file, this one, and the binary file. The binary file can, so the JSON file will reference this one, okay? This JSON file, somewhere in there, if you open it in the browser, etc., you will see that this name is in there. So it references, and this is where the weights and everything are located. So you need to move both of these files to your web application. Is that clear, guys? Are there any questions so far?
I don't have any questions.
No questions, right? All right, perfect. So as you can see, you don't have to do anything with those two files, the binary or the JSON. You can completely just, ignore them basically. But what you would have to do at this point is you don't need the Python script anymore. We're done with that one because that was for developing your model and saving it. You don't need the H5 file anymore because that was just so that you could generate these two. So literally all you need now is to move these two files somehow, right? So because now we would deploy this in our web application. So what I'm going to do, I've already done this. I already took these two files and I saved them on my GitHub, right? So I saved them on my GitHub so I can access them. All right, so you can see here, now what I'm going to do is I'm going to go back to I'm going to share my, what happened there? All right, so you should be seeing the calendar again, and you can see if I click on my GitHub, click on code, you can see that I've already uploaded the binary file and also the model.json file. Okay, I already have them. So these two are ready. I'm done with this one. These two are ready. All that remains is my index.html file. Okay, so that's the last part. And actually, this would be the hardest because, especially if you don't know JavaScript, right? So definitely, again, in particular, if you want to do this, later on, and just in general, if I would recommend taking a look at new JavaScript, Node.js, and Tensorflow.js. All right, so that's what we're going to do now. Since we have these, we are done with our Anaconda environment, and now we're just going to go to our, let's say now you're moving to the browser, right, to the web server. So let me stop here. And now I'm going to open up my web server, right? So I'm going to use my Ubuntu Linux for this. So let's, I have a lot of files open. All right, so let's open up a virtual machine. In this case, you can use for this, as I said, just because I'm using Linux doesn't mean that you guys have to use. Maybe you have a Windows LAMP server, something like that. Here, this is completely independent from, Python or anything like that, TensorFlow. Now this is just the web, right? And everything is already ready to go. So what I'm going to do is I'm going to start my web server here. I'm going to share that screen now on the virtual machine. You can see here, I'm going to so you should be seeing the virtual machine now. Hopefully. Okay, so you should be seeing the virtual machine. So I'm going to open up the terminal. And you know that we usually put our web files in var ww. So we're going to do var ww. And then I'm just going to, I have some folders in here that I conveniently have available. So then I'm going to do, just going to go there. Okay, and I'm going to go to this folder I just created called ML.jscript, right? So, I'm just going to go in there. So cd ml. Okay. All right. And so you can see here in this folder, I just downloaded the two files, right? So this part, I don't have to demo it. So to speed up the process, I have already downloaded that binary file that I just generated from Anaconda and also the model.json. Okay, I have both of them. So what I'm going to do is I'm going to create a new folder here. And I'm just going to call it in class. Yeah, that should be enough. All right, so now I'm going to move, or I'm going to copy those two files. So just I'm going to copy that group file, okay, into in class. All right, and I'm going to copy the TensorFlow JS, so model.json. JSON. Yeah. All right. So if you notice, those are the two files that I, would have downloaded, that were generated. Right, and you can see them here, right? So ls.l. So I have the bin and I have the JSON file, pretty much the same ones. The next thing we need to do is we need to create our HTML code, right? So we're going to create our HTML code. So for this, we need a new file. So I'm going to do the index page here. It'll be a simple HTML page. So I'm going to do index.htm. Okay, and this is just, regular website, right? So HTML. Oops. So HTML here. Like that. And then I'm going to add, let's add, just the basic parts. So head section, the body section, and the body section. Right? So pretty straightforward, really. Now, what do we need? We need to have an input and a button, right? So let's start with that part that should be very easy and familiar to everyone. So let's do here, let's do an example of, ML on the web, ML on the web, H3. What I like about this is that, you could have all these models. So let's say that you have all these models saved somewhere, and then when people visit your websites, they would have these models ready to use, right, and make them available. So in this case, we're going to say, okay, I need an input. I need an input here. ID equal user input. Remember that we're going to need to reference this by ID. And then this is going to be a text box. So type text. Okay. Input, like that, right? So we have our text box. Let's also have a button. So I'm going to do button. And then on click, right, we need to call a function that we are going to define, and let's call it predict. Now this function will take as parameter the model. So the model, we're going to have to generate that also into JavaScript, so it'll be like a global variable available to it, right? And we do that button, and then let's say that it predicts. And then let's just close it. And that's it, right? So at this point, that's pretty straightforward, I think. Nothing fancy. Then over here, we need to have a couple more things. Now, obviously, you might ask, all right, so here, I know how to do JavaScript. Do I use the script tags? Yes, you use the script tags. So you use script, and you do script over here. But just like you did with jQuery or other languages, we're going to need to have a library, right? So import a library. In this particular case, it's going to be the Tensorflow Js library. So you're going to say some, I'm gonna do something like that. And then script. So these are your script tags to now bring in your library as reference. You guys see that? All right.
Yeah.
So I'm sure there's a lot of libraries out there. I'm just going to use the one that worked for me. So I'm going to go to cdn.js vr.net. And from there, I'm going to get TensorFlow, the TensorFlow JS, so TensorFlow. And then the version is TF. I'm trying not to make any mistakes here. TFJS 2.0.0. And then we're just going to say distribution. And then it's the tf.min.js. And that's it, right? So we've got there our library. Very much like, as I said, like jQuery or other things. So now I'm going to do Control X just to make sure I don't lose this. All right, good. I'm going to open this again. And there you go. So I've got my library now, very, very simply. Okay, I've got, I know I've got my input and my button. So I know that whenever I click, I need to go to predict model. So I need, first of all, I need to load the model, and then I need to use the model. So that's where you need to specify a couple of things. Okay, so we're going to need to, I'm going to create a variable called model, and I'm going to load the model. That model is going to come from that JSON and that binary file that that we already have in the folder. So to do this, then I need to specify this function load. So here we're using new JavaScript. Okay, so because we're using new JavaScript, we're using async. We're going to define it as an async function called load. And we open curly bracket, close curly bracket. So that's going to give us that's the load function, right? So obviously you might imagine this is going to make a reference to that JSON file, maybe that binary file. The other function we need down here is, once we have the model, right, we need to predict. So we're going to do function predict. Predict will take the model that we just loaded, this one, right? So we're going to take that model. So then we're going to say function predict model, open curly bracket, and close curly bracket here. All right, so we've got that now. So the function predict, all it has to do is it has to take the data from the text box, convert it to a tensor, and then run it in the model, and then show the results, right? Now the load function needs to load from the JSON file, because we only need to load from the JSON file because the JSON file refers to the binary, so that the path is there in the binary, right? So in the JSON, you have the path to the binary. So then here, all we have to do is now I'm going to create, a URL, the URL of my server, right? My server is, I'm using a VM here. So if you were deploying this on the web, it would be like your IP address or your domain name. But, obviously you could use PHP to like query a database and then all that. But here I'm just going to do, keep it pretty simple. So I'm going to do HTTP local host, right? Which is my local host for my VM. Could use the IP of the VM. And then the structure is test. So I need to know where my files are in var ww. In this case, test2. Then I created a folder. You can see it at the top, right? So it's up here. It's ML JS JScript in class, right? In class like that. And then the file. So the file is the model.model.json, basically. As you can see that there. That's it. So I've got my path, right? I've got my URL defined. Now I can proceed to just load it. So I'm going to do const model equal, and then here we're going to use these synchronicity things so that things can load, you know, like JavaScript kind of loads in parallel to HTML. So we're going to say await here to load. So tf dot load. And this, notice now the TF. So I should stress, notice now the use of the word TF here. Why can we use this? Because we've got the TensorFlow JS, right? We've got the TensorFlow JS. So now we can use this. You can actually build neural nets this way, but you know, since we use Python usually, we're just going to use this for loading the model. So TF, at least in this example. So TF load layer or layers model. And we need to specify where it is. So that's why we wrote the URL. So I do URL there, and that's it. Now I have the model hopefully loaded. This can access the JSON, and the JSON accesses the binary. And once that's done, we just return model, and that's it. Obviously, that's this function here. It returns model. And so we have our model available to us. And that's it. Okay, guys, any questions so far?
I don't have any yet.
All right, great. So now let me save so I don't lose all of this. I'm going to open it again. All right, so we've got my load function created. Perfect. I've loaded my model. Perfect. And all that remains now is to deal with the predict function. So as I said, with predict, it takes the model, right? It takes, you know, the model as an argument. So the first thing we need to do is we need to grab the value in the text box, because that's going to be the number as I showed you guys. So the first part is usually just getting the data. So const user input, right? So user input, and we're going to use you know, document dot, you know, get element, by ID. And, you know, the element is going to be this one down here, right? So that's user input. So I'm going to do user input. And then from it, I'm going to take the value. Okay, so I have the value, that number. Great. Now the next step is we can't feed that number directly like that. Remember that TensorFlow only takes tensors. So we need to convert this into a tensor, but we have now TensorFlow JS. So then I'm going to do const, and then I'm going to say input tensor, and again, I call, notice, TF, right? So I'm calling TensorFlow in JavaScript, and I'm going to say tensor, tf.tensor, and now I'm going to plug in my value here. So what we're going to do is we're going to put this in square brackets, and then in here, we're going to take our input, user input, but we're going to pass it through a typecasting function. So in this case, we're going to say parse int. Make sure it's an integer value. So remember, with TensorFlow, one of the key things is to get everything, all the data types and the dimensions of the tensor correctly. All right, so this is where, you know, learning a little bit more about, you know, the new JavaScript, Node.js, and Tensorflow.js would be very helpful. Okay, because your problems may be a little bit more complicated than just this, right? So that's where this is useful. But as you can see, the logic is pretty straightforward. We've created the input tensor, TF tensor, and then we have it parse int, just making sure I didn't make any mistakes. User input. Perfect. All right, so I have now, my input is ready, and now I want to use the model. All right, and the model, the way it works is, I'm sure this can be written in a couple of ways. This is a JavaScript thing. You're going to do model. You take the object model dot then, okay, and so let me get this right. So here it's going to be model like that, and then curly bracket. All right, and then we just have to make sure to close this properly down here. So this is going to be close curly bracket, close parentheses, semicolon. And that's just the way that basically new JavaScript, it's like, remember when you did jQuery, right? In jQuery, you have the jQuery function and you grabbed objects. This is similar in new JavaScript. New JavaScript has this a bit awkward format of doing things, but it's a similar idea. So now you do model.then, and then you grab the model, and now in here you just write the logic that you want to do. So you do let result, let result equal, and what do? You're going to predict. So you do model.predict. Okay. What do you predict on? You predict on your input tensor, which is already ready to go, right? So you do input tensor. There it is. Perfect. Now you have the result. And what you want to do now is you want to, you know, just in case the value is somewhere between not zero, you know, maybe it's if the value is the value, you just want to make sure it's like a 0 or a 1. So then we can do here result equal result dot round. So result dot round. And because this is a tensor, right? This is a tensor. So let's do data dot data sync and specify that it's, you know, the first one. So we've got that. Now we have the result is basically a 0 or a 1 as we had in the training data. And now we can just do the alert. I'm going to do alert. So if result, right, if it's true, then on. Else, even. Remember, you can do this in many, many different ways. This is just an example. And that is it. Believe it or not, that's it. That's all you need to do. So the more complexity, you know, was here, you know, because, you know, really converting the data from text box to tensor and then predicting the value and then making sure the result that you're getting is something that you can use. Okay, I leave it to you guys to kind of play around with this, you know, take it out, etc., and see what the values look like. But at this point, all the code should be ready, right? So in summary, as you can see, we have an input in a text box. We have the predict function and a button. whenever we load this, we load the model from that's this function up here. We have the URL, we load it, we have the model, and then we call the predict function, take the value from the text box, convert it to a tensor, predict, then make sure the data is ready for us to use, and then over here, just print out the result given the input. So let's go ahead and test this. I'm going to do Control X, Y, Enter. All right. If I look at the values, ls-l, right? So I have them here. So my index is ready. So now I'm going to go, remember it's in the in class, so I need to open up my browser. And I'm going to go to localhost, test2. I'm going to change this to another folder. ML, I think it was. Right. There it is. But this is the old one that I had. Now we have to go to in class. In class. There it is. And you can see that it says ML on the web, that the name changed, right? That's the name that I'm giving it now. You can say, you know, ML on web, you know, 360, this is 365. Let's go back to the browser, fresh, you can see 365. So now we should be ready to run this, right? So if I do 3, predict, odd, perfect. I do 6, predict, odd. Okay, it doesn't get that one right, but we know 10. Will it give us an even? Odd. Okay, that's not working. All right, 100. Even. All right, perfect. There it is. Do you guys see that this one came out even? And the other one, odd. Okay. If I do 16, that'll probably say odd. Yeah. If I do 50, even. All right, that's good. If I do 80, even. That's good. I do 92, even. That's good. What if I do 91 or 81, let's say? Even. Okay, so sometimes it makes mistakes. 93, even. All right. 41, odd. That's good. 60, even. Perfect. As I said, you know, if we wrote if statements, etc., it would probably be better. But that's just because of the nature of this problem. Obviously, for more complex problems, like if you had a picture of a cat or a dog, machine learning would be better. And that's it, guys. That is basically how, you know, that's basically how this works. Are there any questions? Does it make sense?
Yeah, this all makes sense. We don't have any questions.
Perfect. Well, that's it. I wanted to show you this. This is, you know, technically the last topic for the semester. So let me just say this concludes the presentation. All right, so let me go back to the calendar. All right, so as I said, this concludes the presentation for this week. You can see the click to the demo. The code is here. I provided all the code, the bin, the index, the JSON, and the JavaScript, and you can just watch the video. But this concludes the presentation. I wanted you guys to be able to deploy your models to your own websites. Now, beyond here, of course, there's a lot that you can do. You can explore, as I said, you know, Tensorflow JS itself, you know, learn a lot there and build much more complex models. And then you want to start trying to benchmark, you know, how fast it is, how efficient it is. But certainly as you start to deploy to the web, I think this is a good starting point for you to do it. And if you guys want to implement this for your term project, that's perfectly fine. Hopefully you should be able to do it, although based on your data, you'll need to make changes in the inputs. All right, so let me stop the video here. So I'm going to stop the recording now.